Um, some of you may not know who I am, so I actually put a slide out there. That I've actually worked in software since 1967, which is before most of you were born. Is that correct? Not you, Erlang, I know you're older, so, and not you, Bjorn, either. But, first I was in Fortran 2 on an IBM 1130 processor. It had 16 kilobytes of memory. Times have changed considerably. I joined Ericsson in 1970, and I spent a long time developing software in C and assembly language. I remember one thing from that time, that I wrote a real-time calendar in assembly language. And you may remember that just before the year 2000, there was a great panic in the world. The world was going to stop rotating because everything was going to go wrong with the year 2000 because of the great 2000 shift. So they asked me just to look at my code and say, you know, does this really work? And I looked at my code written in assembly language, and I say, have I written that? I wrote it. It just shows you how quickly you forget things. Anyway, I worked for the computer science lab. Bjarne Dekker, who sat there, was my manager. A few years later, I became Bjarne's manager. So it was. And I also fired Bjarne, which also he was actually. I think we fired Bjarne. I think we then went out and celebrated afterwards because he got a good deal.
Why do you look so worried on the photo?
I always look worried, Bjarne. It's just part of my sort of behavior. We had a crazy idea at the time that, I introduced Unix to Ericsson, and I was actually the person that wrote the first virtual machine, which I think we talked about yesterday, Joe's abstract machine. I actually implemented it in Erlang. And then people like Clacker and Tony took over the machine and made it work properly. But my machine was actually used in a product for a number of times. It was the first time I think that I ever had the problem of sort of telling people that the weird error messages which came out actually meant something. We then got the weird idea that we'd sell Erlang. We started a company, and there's a long background history about this, which I will not go into, called Erlang Systems Aktiebolag. Aktiebolag is limited in Swedish. And in one way or another, I actually landed up becoming the managing director of this company. It was the smallest company in the Ericsson concern and the least profitable company compared to its size. It was me, the secretary, and the salesman. We sold one system to a guy in Alaska, Ulf Viger, who some of you might know. And then I decided that I'd do better things. So I gave up trying to sell Ericsson. In one way or another, I became a manager, and I worked as a manager in Ericsson for about 20 years. Just about 2 years ago, I decided I had enough managing people, and I wanted to take life easy, so I did a few other things before retiring. So nowadays, I do exactly what I want. If I write software, I write software. I want to write myself. I don't do anything anyone conceivably other than myself might want. So that's my background. I've observed a large number of projects in various ways of working and see how things work. I know vaguely what works. I have a very good intuition. I can say very rapidly that this won't work. I find it very difficult to say to the project, this will work, but weeding out the ones that won't work is very easy. So finding out the ones that actually will work is more difficult. The first thing you have to remember about programming is that not everybody is actually very good at programming. In fact, most people are absolutely lousy at programming. And if you look at the people that confronted with the weird interfaces that they have on trying to sort of control their video recorders once upon a time, or trying to sort of take their Android phones and all the rest of it, hardly any of them. It's very, very difficult for the average person to do these things. And that's not even programming. They haven't got very far. The average person finds using something like Excel very difficult, despite the fact that a lot of people can use it. Now, you people all here know how to program, and it's not, you probably find it difficult to understand. But most people can't program, and they will never be able to do that. Of the people that can program, there is a huge difference between the people that do it well and the people that do it badly. That the figure 15 is often quoted as a matter of productivity. But it's not even just a question of that. That's the people that can't program, they also write lousy programs, and they are full of bugs. So the difference between a really good programmer and a lousy programmer is, you can talk about factors of 100 easily. What can you notice about good programmers? Well, firstly, that all good programmers are incredibly egocentric. You've probably seen Joe on stage, and I think that no one would deny the fact that he has a slight touch of egocentricity in his personality. The other thing about... get this thing. The other thing you can say about good programmers is that good programmers don't understand the need for project management. A really good programmer can manage themselves. And I was talking to someone, actually also Joe, the other day, and he said, in Ericsson they do things in a strange way. They want people to write implementation proposals before they actually write any code, and they pass the implementation proposals. He thinks that's crazy. Why can't you do straight off and implement things? Well, this is simply because if you have a project, the last organisation I managed in Ericsson had 140 programmers. And if you talk to people, a good programmer will say, well, you don't need 140 programmers. Well, it's not true. You cannot recruit in a large organisation 140 programmers. It costs too much, and they aren't available. And probably they don't want to work with the sort of maybe radio-based stations or everything. They want to do cool things like writing nice graphical interfaces or protocols or management protocols. They want to manage money. Getting 140 good programmers in a normal industry is just not possible. And you have to realise you're going to have to work with maybe 10 good programmers and 130 mediocre programmers, and quite a lot of those mediocre programmers are not good at all. And that is the reality of life. And this is what good programmers don't understand. Good programmers never understand that other programmers aren't as good as they are. You can also realise that people can be good at incredibly different things, and very few people are good at all of them. I've written some of them. Knowing knowing the domain of what you're trying to program is probably more important than understanding programming languages or databases or whatever. Actually understanding in detail what is it I'm going to program and why am I going to do that is the most essential characteristics. That in the position I had in Ericsson at that time, I said 140 programmers. We were actually writing part of the software for radio base stations. The actual number of programmers working in radio base stations is probably about 300. So I was doing about half of it. At least I wasn't doing half of it. I was telling people how to do half of it, which I wasn't even doing that. I was watching while people did half of it. And you can realise that of the 140 I had about 5 or 6 that really understood what they were doing. And the rest of them were actually having to be told by these 5 or 6 people, this is what you need to program and this is how you need to do it. Okay, other people learned, but knowing how to manipulate the weird systems you have and the weird programming languages you have, and then also being able to be very good at the application domain is very, very rare. I think most of you listened to Clacker earlier on his keynote. Clacker is an incredibly rare animal. Clacker can actually understand everything he does about his management systems. And what's more, he's an extraordinarily good programmer. With certain exceptions. I had to correct some of his code. He never realized that strings ended with a 0, and if you did a malloc on a string, you had to do a malloc's string length of 1. So the first thing he did with Clacker's code was grept for string length, and add 1 to all the answers. But the worst thing, that's an awful sort of bug, because it works one time in 4 on a 32-bit machine. However, technology you have to be good at. Some people are good at that. Some people are version control. Testing is a weird animal. I saw a quote the other day, I can't remember where it came from, that all good testers are good programmers, but not all good programmers are good testers. Which is very true. To being able to have that perverse attitude that I'm going to mess around with the system and make it go wrong, you have to have a sort of sadistic attitude, I think, towards the programmers. I'm bloody well going to show these people that they can't write code and find the bugs. So testing is a bit, just being able to do release handling and delivery is a skill which is very underappreciated. There's a lot of things, but the thing to remember in an organisation, I've never met anyone that's good at all these things. There are very few people that are good at these things. And one of the first things I say if you're going to run your project, make sure you have at least one person in your project that understands at least everything that needs to, one of these things. No one will understand all of it, but if you're going to start a project, go through the people you've got in your project and say, have I got someone that can know all that is necessary in my organisation? If I haven't got that person, go and find that person, and if you can't find that person, don't start. Do something else. It's brutal, but it's true. During the time, I discovered there are a lot of people that don't want to use languages. I used the example here of Erlang. I've seen this in other cases. The most prevalent thing I saw in Ericsson was not people that didn't want to use Ericsson, who want to use Erlang, but people that didn't want to do modeling with a wonderful thing called Rose Real Time. I think that some of you have seen Rose Real Time, but it is the most horrible programming system I have ever seen in my life. And I had great sympathy for people doing this, and I had a great problems to try and persuade people in my organisation that it was very good. I couldn't even pretend myself that it was very good. I just said, this is what you have to do to get the system out. Very sorry, folks, you have to sort of live with it. However, I met in my life sort of a number of people who didn't want to use Erlang. And what did I now find? I can give you some examples. There was a group of people in some little organisation far north of Sweden that decided that they wanted to make Erlang object-oriented. And they got the weird idea they could do that by modifying the error handler. You know, the error handler is when you actually call a function in a module which isn't loaded. And it gets the error handler, and what it does is it calls the loader. So they had this wonderful idea, if this function didn't exist, I would try and work out which module it should be in, and sort of find out a sort of superclass and try and work things out that way. So they changed the error handler. I wonder if I can stop this bloody thing. Turn off Wi-Fi, presumably. Changed the error handler, and to their amazement when they stopped doing that, they found that code loading suddenly stopped working. And so if you don't want to work with people, they don't want to use the system, and tell them to use something else and go away. There were another group of people, and also in very close to Stockholm, that got the idea that they wanted to work in object-oriented fashion. And this was the time when we only had 32,000 processes in Erlang. And they made every thing that they considered to be an object in an Erlang process. The result of the case is you land up in the most horrible sort of scheduling mess, and you confuse. You don't actually see the real concurrency because you've disguised it with everything else. And I don't think they ever got anything to work. They just, I think that project, thank the Lord, was actually discontinued before anyone ever tried to deliver anything. There again, they do wanted to change it. Another nice example was, this was a wonderful people in Los Angeles, in Ericsson Business Communication Systems in Los Angeles, who got the weird idea that they wanted to make a support system for Erlang, which is a very good thing to do. At those times, the tools, the debuggers and all the rest of it were absolutely crap. But they didn't like Erlang, so they decided to make the support system for Erlang in Smalltalk. Which is also weird, because if you're going to do something, the Americans got a nice expression, which is eat your own dog food. That if you're going to use Erlang and you want to make a support system for Erlang, for God's sake do it in Erlang, because you do it in Erlang, you might have some idea of what the problem is you're trying to solve. So they made this huge support system in Smalltalk, which never ever was used by anyone, and they enjoyed themselves for about 2 or 3 years, and then the whole thing was dumped. Then we had the people that decided that SNMP was a good protocol for managing systems. You heard Clacker earlier about this. And they communicated between two Erlang systems, the manager, which was written in Erlang, and the application written in Erlang. They decided to communicate this in SNMP. And SNMP maybe is good for management, but it certainly isn't good for issuing complex commands. And this was horrible. The MIBs were such that they were the MIBs were thousands of pages long. And it was just totally incomprehensible, but they tried to persuade them this was a bad idea. It just didn't work. That product was actually delivered. I think that the people that actually received it were not very happy with the result. yeah, we had the people that decided that they'd already designed their own system in C++ with a lot of concurrency, and done a lot of systems work, and then they got the idea to use Erlang, and they were actually told to use Erlang, and they said what we'll do is we should actually graft our system on top of the system that we've already written, and messed around with it completely. And of course, if you're starting using Erlang processes and then have a sort of idea that you're going to communicate via shared variables between threads, you land up in a slight problem that there aren't any shared variables between threads. And this causes, again, problems. What else? I could go on for ages about this. There were people in I think they were in Holland, if I remember rightly, but maybe wrong there, who decided that they didn't like OTP, therefore they would write their own schedulers and everything on all supervision systems on top of OTP and write and modify it. But they'd use OTP, but then they'd do everything by a layer on top of it. I think it was called the process abstraction layer, wasn't it? Do you remember that, Fiona?
Don't forget the example of the chap who wanted to put secure message passing, so every message passing was echoed.
Oh yeah, that one. Oh yeah, that was wonderful. Yeah, every message passing was echoed back to make sure you actually got it. And that was also sort of absolutely wonderful. So the second moral is that don't tell people to use Erlang if they don't like it and they don't understand it. If they want to use something else, well, either go away and do another project or let them do it the way they want to do it. Don't force things down people's throats that they don't like, because it won't be a success. It causes problems, and I've seen it. It's not only a thing about Erlang, but don't force people to use technology they don't like. That programmers are strange people. They have their. It's like driving a car. Some people hate driving sort of some cars, and some people hate driving others, and they sort of have strange views about it. But yeah, then of course we have the typical sort of organisation, and this really dates back from the days that when you wanted to program something, you actually punched a lot of cards, you handed them in through a window in a computer centre, it came out the result, and then you this is the old-fashioned attitude. And the way it all worked was that, and it's worked for years in companies like Ericsson, thank the Lord they're changing it nowadays, that you had a systems department. A systems department, I'll get on to what they did, and then you have a programming department to write the sort of program, a test and delivery department, and on the side of that you have a bug tracking thing, so everyone can report bugs and everyone can check the whole thing works. And this is the theory, and it all looks very nice, and if you sort of people that believe in this sort of flow and nice sort of theoretical things, that in one part of Ericsson at one stage, I can probably tell you, it's nice to be able to tell these stories now that I've left Ericsson, because they can't sort of fire me anymore. That they had a whole unit whose sole purpose was to invent processes for not processes in the machine, but processes for how you worked. And what they did is they put up in the wall of a room, they put a great bit of plastic, and they wanted to put post-it stickers on it. Now we'll do this, and now we'll do that, and now we'll do the others. And they had a huge, I think it was 40, 50 people that spent all their days working out how other people were going to work. They'd never actually worked in that way themselves, so they had no idea if it was going to work or not. It was completely amazing, and people developed this sort of thing. I'm sorry, I won't actually spend time sort of working out how to turn off my Wi-Fi. Oh yeah, wait a minute, I can press this magic button here and turn off the Wi-Fi. That'll do the job, I hope. So what actually happens when you design this organisation? Well, what happens to the organisation is, of course, that Microsoft invented something called PowerPoint. And PowerPoint is wonderful because you can actually make nice diagrams without having to think. And you don't know if they work or not. So that you get a sort of mad PowerPoint developers that make a lot of PowerPoint slides they send to other people. And then, of course, you have people that think that modelling is the solution to everything in the world. And they write models. And these models they pass on to the next people, who are the PowerPoint and mad model interpreters. And they try and work out, what the bloody hell does this mean? Why has anyone done it this way? And it's sort of they try and get something to work. And of course, if you make a model, everything looks very nice, but then you forget all the error cases and everything that goes wrong. So you actually push all the responsibility down onto the programmers to work out the strange things, happen. The other thing which happened is you actually never really understand the way something works until you've programmed it. And when you've started programming it, that's the first time you actually understand how things work, because you're forced to deal with every single little sort of tiny detail of what happens. But of course the bad modelers, they never do that, and the PowerPoint designers, they do that even less. And then of course you get the bottom level, the bug reporters, these are the testers. Now in this organization you find that there are a certain number of people that don't like programming. I don't quite understand that, but there are people that don't like programming. And they migrate in two directions. The people that have got a great ambition in life to get more money, they go to the top and become mad PowerPoint modelers, because that's a sort of nice thing. They don't have to pump program, they don't have to think very hard, and they get paid very well because they're called systems people. The systems people always get paid better than programmers. And then there are people that sort of aren't really that keen on sort of programming, but not so ambitious. And they move down to this level, to the bug reporters, because they don't have to program either. They just execute test cases and see if they work. It's very, very nice. You find a test case doesn't work, you actually submit a bug report to the little bubble, the right bubble on the right, and then you drink your next cup of coffee. You don't have to fix the bug report, you just have to write the bug report. Anyone can write a bug report. You don't even have to say where the bug is, you just have to say it didn't work. That's life. And then of course you have this wonderful sort of thing which was actually intended to be a bug tracking system. And the bug tracking system turns out to be the only way that these three separate entities ever communicate with each other. It's only at the end of the day, when you actually have to deliver something to a customer, that you sort of get mad teams of people that start working together and running around in circles and make things work. You can actually make this model work. I've seen it work, and I've seen people deliver things, but it's an uncomfortable way of working and incredibly inefficient. And then, of course, you can make it even worse. That if you take the sort of middle bundle of the programming departments, and then you have several programming departments located in several different geographical locations. I can give one example here, which I'm sure some of you might know something about, when we had one programming department in Holland, another one in Norway, another one in Montreal, all were working together. And notice well, you put things in different time zones as well, that makes it even worse. Then we had a test department in Stockholm and another test department, I think it was in Research Triangle Park in Raleigh in America. I can't remember the exact details. And then you have a sort of bug tracking system to try and sort of let these people communicate with each other. Of course, the bug tracking system becomes the only possible method of communication, because people are sort of sitting in different time zones and they can't even phone each other. It's you can make things. You can actually make this sort of thing work as well, and I have seen this sort of thing work, but it is incredibly inefficient and incredibly frustrating way of working. Okay, that's the sort of organisation. Then you have projects. And you have to realise that projects are very, very different. It's not only a question of the people working in the project. You get some projects with very small groups of very excellent programmers. You get some projects with mediocre programmers. You get some projects with people that can't program at all. They never produce anything. Then the business of trying to program something for the first time is very, very different from the first one. I'll get on to why. From actually a project which would actually mean you've got a big project up and running and you're making a product, but actually trying to get something working at all for the first time is difficult. And then of course the maintenance. You've got a project, you've got a product and it's running and you're getting bug reports from customers, and maintaining that product and keeping it going is very, very different from that. Now, there are, I'm getting ahead of my slides, so I'm careful. So, what you see about the project, what are the difference of the types of people? Well, doing things for the first time, this is you need bold, wild people. You need the clackers of this world who are prepared to sort of write code, throw it away. Tony Rovar's another person I respect highly in this respect. Can write code, throw it away, try again, try again, until you get it right. You need it's a trial and error business getting the architecture right, and it's trial and error. You cannot get an architecture right unless you've done something before, then this is the third time you've done it. You cannot get it right without doing experiments. And people don't really realize that the so-called prototypes or experiments that you do are absolutely vital to getting things right. And then, of course, you get the sort of making a product. And this is very different. You actually have at this stage, hopefully, done the experiments and you know what works. And if you know what works, you're actually filling it out and implementing it, and everything is maybe not beautifully specified, but at least you have some specification. You know roughly what you're doing. And then, of course, you've got the maintenance project, where actually you're fixing bugs, you're making enhancements, you're doing things like porting your system to new versions of operating systems and none of that sort of thing. That is also very, very different. Different way of working, different number of different type of people needed. Going on from there, that you look at the different types of team you need for these. Now, the first one, if you're starting doing that with more than 8 people, I heard the old one that you should never have a team which is larger than the number of people which were once required to hunt buffaloes and kill them, because this is the number of people you need. You need a tiny team to do the first one. You cannot do that with hundreds of people. And because you can't have you can't have 100 people all doing experiments and all throwing away code in totally uncoordinated fashion. You need a team of very good, excellent people. They need to combine the knowledge of domain knowledge, and they need software technology. Hopefully, it's done in the same person, but you need one person that's excellent in software technology, and you need one person that understands the domain and understands what needs to be done. Then further down, you need several small teams. Software technology at this stage is what becomes more important, because hopefully you've actually worked out in the first stage what needs to be done. And it's how to make software, it's running tools and how to debug systems. That what becomes important at this stage. And at the end of the day, when you have a system which is going to live long and you need things, you also need a small team. You need a small team of people to correct the bugs, keep the system alive, keep it running, port it to new operating systems. And these people actually, the most important thing for them is not the actual software technology, it's actually knowledge of the domain, to understand what the problems are, what the customer needs to do, what the customer needs to modify. That's absolutely important. So you have software, the beginning, small, software technology, domain, middle, software technology, at the bottom, domain. And of course the middle bit is the big bit, where that's where you need maybe hundreds of people. And then of course you get different type of people. I mentioned egocentric individualists at the forefront of technology. Those are the people you need at the beginning. They have to be completely nuts. They're the real nutters. You need them, people that can feel that they're doing something new. And in the middle you need a different sort of person. You need a person that actually enjoys working in a large organization. The people that you have in the first stage find it very, very difficult to work in the second stage, because they're having to work in an organization. They're not the sort of people that can do that. You can find examples of people, I'm not saying that there are, of course, exceptions, but you need team players and you need people happy to work with the technology, think that working there, think that what they're working is a good idea. By the way, you never need to have people that in a project that think the product that they're making is a stupid idea. Get rid of those first. And at the end of the day, you need long-term people. That people, you know, one of the most important characteristics of maintenance is being able to understand other people's code. To understand code for people that have left the company 10 years ago and now work for someone else. That is an incredibly difficult thing. And I personally think, and I'm good at understanding other people's code, I actually think that understanding other people's code and why it's written is actually more difficult than writing your own code. And I don't think people actually realize that. The other hand, you want people here that are really happy, they like their jobs, they're going to stay in their jobs for 10 years while the product lives on. It's very, very difficult to get those people that are prepared to do that. And it's very, very difficult, once more, to get the sort of stupid human relations management people to realize that these people need to be very well paid. Because unless you pay the maintenance people a lot of money, they're going to change jobs, and the knowledge that they have in their heads is going to disappear. Incredibly difficult to realize. If you look at the sort of payroll, you should have these people should get paid most, the individualists that do the things should get paid second most, and the people that live in the middle and actually decide they should pay third most. You can change these people, you can't change the first people, and you can't change the second people. Okay, the first people don't have to stay in the project all the time, they just have to get it going, but these people maybe have to stay there for 10 years. I used to say in Ericsson that the greatest enemy for Ericsson was not Huawei, the Chinese manufacturer. It was actually the HR departments that didn't actually understand two organizations, both beginning with H. Big companies have HR departments. HR departments never understood the way software is developed. Great mistake. In many organizations, time to market is critical, and they jump straight to the second making product organization. I've seen many projects where the first thing they've done is saying, oh, this project is going to require a large number of people to develop, and therefore we'll recruit a couple of hundred people to start with, and we'll go on with that, and we'll do that. If you do that without doing the first stage, you just don't know what you're doing. You have a system where people are doing experiments in a context of hundreds of people, and it always goes wrong. I've seen it go wrong time and time again, and it always results in a product which creates a massive cleanup afterwards to do anything about. You can do it, but the cleanup costs an enormous amount of money, and you live with a system which is badly designed for the rest of its duration. And in point of fact, you don't save time. This is what people don't understand. You don't do it to save time, because the mess you create is so great that it takes such a long time to clean up and get the first product working that it's just not worth it. So don't do it that way. Always, if you're going to make a new product, make sure you have a new product organization, a new product phase first. Organization, I started with the middle organization. That you noticed I had the department, I had the pictures of systems departments, programming departments, test departments, software. This is the way to do it. The unfortunate thing is that people don't really realize that you actually need the top and bottom bubbles as well. But they're not system departments, and they're not test departments. They're tiny groups of people that hold it all together. You're going to need a team at the top to coordinate everything, to make sure interfaces between everything work, to keep everything. You can't get away without having that team. But it has to keep, if it's more than 5 people, then something has gone desperately wrong. I've seen that in certain organizations get to a couple of hundred people, and that's desperately wrong. You need someone that actually puts everything together, delivers it and tests the whole product before you deliver it. You need that, and maybe that's 15 people. And then of course you can have countless of teams in the middle that put things together. But in these teams, you have people working together who are good at systems work, who are good at programming, are good at testing, and hopefully combine those skills in the same person. But you need lots of these. You can't get away with it. An important thing about these is you should actually make sure that each of the bubbles, teams in the middle, work with a defined role. They should work with a defined part of the product. They should work with the GUI, the interface. They should work with the database, so they should work with that. You shouldn't think that you can allocate work to these in a sort of random sort of fashion. People actually have to know and understand the part that they're doing. And actually understanding what you're designing and why you're designing is absolutely much more critical than actually understanding anything else, and more time consuming. That you probably can learn programming skills provided you're reasonable effort hours. Learning actually how a product works or what it does is far more difficult. Organization, I've kept one slide for this, yeah, sure. Organization that developing is made the first time, one small team, and keep the team small. And remember that maintenance and doing something the first time requires different sorts of people. Recruitment is a problem. Most people like doing things for the first time. They think it's fun. And it's very hard to recruit the top people to do for product maintenance and for product development. And you have to realize that if you do this, you're going to land up with people who are not the top talent in these organizations, and it's difficult to keep people there. It's in all recruitment, don't forget that there's a rule. I call it the what, why, how rule. You have to understand that people both know what they're going to design, they don't know why they're going to design it, and they've got to know how they're going to design it. And what's more, they have to like the ideas in all these things. You can't sort of do this if people sort of hate the idea of, oh God, I have to design this, they have to use this horrible tool. If you have such people in your organizations, they're going to spread discontent and cause problems. Another silly idea that people get round to, and this is a wonderful idea that I've seen in very many organisations, not just Ericsson, is the idea that we can make things a lot cheaper if we transfer the whole product to India or somewhere like that, or China or something like that, because the Chinese engineers didn't do that. There are several reasons why this is a bad idea. One of them is that if you transfer everything to a low-cost country, that low-cost country very soon is going to become a high-cost country. The other reason it's a bad idea is the people that you transfer it for are sooner or later going to say, hey, wait a minute, I can do that myself. I don't have to I spawn off my own private little organisation and make money selling the same product. You're teaching people to do your own product. I'm not saying anything about the skills. I'm pretty sure that if you look at the sort of skills of people in China and India, they are every bit as good as what you can get in Europe. But they do charge less, and people there don't have the same loyalty to the company and the product that you have. So it's not only cheaper, it's maybe cheaper on paper, but the actual cost of transferring something is enormous, and the loss of knowledge. No system is ever properly documented. Most knowledge of systems is in people's heads. And that is an enormous problem, that a head full of knowledge is a lot more than you ever can get down on a sort of some formal specification. You lose information, you have buggier systems. Okay, the cost per hour is less, but you're going to use a lot more hours and you're going to have a lot more bugs. Not because you're transferring it to bad people, which is simply that transferring anything from one place to another costs a lot of money. Yeah, I thought that this track was called Agile and something, so I actually had to say what my view of Agile really was. But I think Agile is a very good thing. And the main reason I think Agile is a very good thing, because it becomes popular in this. A number of people have written books about Scrum and XP and all sorts of other ways of doing it. And it's actually something the management can actually understand and realise that this old-fashioned ideas of having systems department, programming departments and test departments is a bad idea, and you need small teams. And for that reason, if Agile means you can break down these wonderful ideas and do it more sensibly, then it's a good thing. You also have to remember that there are two aspects of Agile. One of them is creating teams of people that work together in a group rather than separate individuals, separate organizations. The other one is that, of course, you have to have something which speeds up the program, test, debug, correction. Programming is a trial and error process. You write code. The first thing you do is you put it in the compiler. The compiler tells you all those syntax errors you've made. You correct the syntax errors and go back again. No one actually spends their time staring at a program for hours to get rid of all the syntax errors. The compiler does that for you faster. At the same time, no one spends their hours looking at all the bugs. It's much better to run it through a test suite and see what goes wrong, because that will tell you what goes wrong. It's a lot faster than trying to do everything theoretically. And it's the second one of these two, that's where Erlang is absolutely excellent. It's because the Erlang's debugging tools, I find that they're far better than any tools I've ever seen for developing C++ or Java or something like that. The symbolic information which is left in the system because it's dynamically typed is incredibly useful. You can pinpoint where bugs are very, very fast. The other thing, of course, is the dynamic code replacement. I think I mentioned this yesterday as well. It's incredibly valuable for testing. You don't have huge build times. You can correct something, recompile a module, often in less than 30 seconds. You've actually put that thing back in your code and running your test cases without interruption. Just dynamic code. So the actual design cycle is absolutely ideal for Agile programming. I'm sure there are other aspects to Agile and all the rest of it, but this is what I think about it. Okay, a summary. The ability and skill areas of programmers are incredibly different. Programmers are different beasts, all of them work in different ways, and make sure you have people with the right mixtures of skill in your programs. If you want to use Erlang in your project, make sure that people like the idea and think it's a good thing to use. If they want to use Smalltalk, if they want to use Prolog, if they want to use PHP or whatever you like, well, and they don't want to use Erlang, well, either manage to convince them it's a good idea or drop the idea, use something else. Don't set up organizations with separate systems, programming, test units. That's old-fashioned. Developing something the first time, product development and maintenance, completely different ways of working, require different organizations and different people. Realize that, and don't try and cut corners. It's hard to find good people for product maintenance and product development because they don't want to work with that, they want to work with new cool things. Realize that, and realize that you actually, in many systems, you have to work with teams of mediocre programmers. You won't get the best people working in these areas. It's an unfortunate truth, but recognize the truth and make sure at least you've got a few very good people. Transferring code from one organization to another, bloody waste of time. Don't do it unless you absolutely have to. There are occasions when you have to do it, simply because you haven't got people who won't play it. And I think the last one is Erlang OTP. I think is highly contributive to the Agile paradigm. I think it's one of the real advantages of Erlang that people often don't realize. Another comment I heard the other day, someone say that in some organizations people say that, oh, we can't use Erlang, it's far too complicated and difficult for our programmers to do. They like Java and they like imperative programming. Yeah, incredible, isn't it, the people that say such things. Erlang is actually incredibly much more simple language than C++ or Java. Incredibly much more simple. You can teach people it very, very shortly. And the people that sort of go around thinking that just shows that what an incredible number of prejudices there are against changing things to a simpler paradigm. Well, that's all I've got to say. If you have any questions, please go ahead. Any questions, anybody? No? Yeah? That is a problem. You have to make sure that the people at the beginning are prepared to write something down and they hopefully have made a prototype and they hopefully can use that prototype as teaching material for the other people. You also have to make sure that some of the people actually from the first phase move into the second phase. It's people's heads that transfer information. It's not bits of paper that transfer information. But some people have to move. But you can say to them, okay, I'd like you to continue this for the next year and I'll pay you well, and then at the end of the day you can go somewhere else. But for goodness sake, during that year, your job is not to go on developing new stuff. Your job is to teach the people what you've done. Yeah.
I think don't you have a step before you collect your group of talented programmers, because what they are going to implement is usually some, at least in telecom systems, some kind of specification, maybe originating from 3gpp.org. So what do you think happens when you give this thick specification to these talented programmers? Do you think they like those specifications? I mean,
they absolutely hate those specifications.
I mean, isn't this a problem too?
It is
have this step before.
It is a great problem that, and this is why the ITF and the RCF way of working is so much better than the sort of telecom way of working. Basically, if you make an RFC, if anyone's going to listen to you, you have to have implemented it first. If you implemented it first, then of course you don't make specifications. A lot of these huge specifications are incredibly complicated and incredibly overworked. They're much more complicated than they need to be. But it's a great problem getting people to write the specifications, and it's an even greater problem getting people to read them. I don't have a good solution for that problem except saying, if you recognize it's a problem, then you might be able to do something about it. If you don't realize it's a problem, then you've got a bigger problem. Yeah?
Concerning the definition for what's a good programmer or really good programmer, you can imagine somebody works very fast and makes very good code as a top programmer. But if you have to go one step down, you have to choose between speed and quality of the result. What would be your opinion on that?
I think you actually have to combine people together. There are some people that are very, very fast at programming and make a lot of errors. And there are some people that are program systematically don't work quite so fast and get the higher quality. all in all, I'd go for the second category, people that work slowly but get it right, because I think the people that work fast and get it wrong are probably, or make a lot of bugs. But at the end of the day, create more work for people at the end of the day creating them. But I think that the best solution is if you can get people to work together, and so that a good programmer can work together, with good fast programmer can work together with a good systematic programmer. That time and time again, I think the best way of doing it is to someone actually prototypes code and then someone else rewrites it afterwards to get it good. Different sort of people.
The third quality which I see is this person who really knows to self-estimate how well he did it. So if he says, okay, this is solid, it's solid.
There are so very, very few of those people.
Okay, I think we're out of time. Thank you, Mike.
Sure. Thank you.